इस बारिश के साथ हम भी आज आ गए हैं चेन्नई तमिलनाडु में। वेलकम टू भारत क्लाइमेट स्टार्टअप। हमारा आज का ये भारत क्लाइमेट स्टार्टअप रेवोल्यूशनाइज कर रहा है हमारी भारत की ग्रीन इलेक्ट्रॉनिक्स मार्केट को। एंड यू हैव टू वॉच दिस, वन ऑफ द मोस्ट रेवोल्यूशनरी स्टार्टअप्स आई हैव कम अक्रॉस। हमारे फोन्स, लैपटॉप्स, शुगर स्ट्रिप्स, हमारे वेयरेबल वॉचेस, हर चीज़ में जाता है सर्किट बोर्ड। बट एज वी ऑल नो, ई वेस्ट इज़ अ ह्यूज इशू और इन सर्किट बोर्ड्स को डिस्पोज ऑफ करना बहुत मुश्किल हो जाता है बिकॉज ऑफ द मटेरियल दे आर मेड ऑफ। हमारे भारत का ये क्लाइमेट स्टार्टअप बना रहा है यही सर्किट बोर्ड्स सस्टेनेबल मटेरियल पे ये यूज़ कर रहे हैं, ये बायोडिग्रेडेबल सेलुलोज टू क्रिएट सस्टेनेबल मटेरियल वेयर योर सर्किट बोर्ड्स कैन बी मेड ऑन।
We are Bharat Climate Startup, Karotimam Innovations. Hi, we are from Karotimam Innovations Private Limited. I am Dr. Chitralekha. I am the CEO of this startup, and this is Sanal Mohanan. Please introduce yourself.
This is Sanal Mohanan. We too founded this company. We are into sustainability and green electronics. Go ahead, ma'am.
Welcome to our green electronics. This is the substrate from which we are actually making this product. This is the substrate. This has been made into a sheet like this through a patented process technology. You can see this is wrinkle free, so that you can print any kind of circuit over this, and you can surface mount it with electronic components like this. Usually what's available in the market is this is the PCB board. Okay. This is a plastic reinforced with some other fibers, and on which the people are it will be coated with a copper paste or something, and that will be etched with some chemicals which is very hazard to the environment, and finally these holes will be made and the circuits will be soldered to this system. Okay, so this will go to any kind of electronic component, means electronic or electrical system. There would be some kind of a board like this inside. Okay, problem is that this one takes long time to decompose,
and sometimes it doesn't even.
Yes, doesn't. And also it's very difficult to handle or reuse these things or recycle this, because problem is that the volume is huge compared to the production. Okay, so the e-waste management is one of the major problem people are facing now, and because of the lot of innovations happening in industry, especially in printed electronics, new kind of products are also coming. This is a flexible electronics component. This goes to touch screen. The problem is again that this is also been made in plastic kind of thing. Okay, this is also going to contribute to the e-waste because of the flexibility and foldability of our substrate. See, this is foldable, flexible, okay, and also rollable. We initially want to enter into the flexible electronic industry. Okay, so that's how we entered into this industry, and we started working on this, and it can go to any kind of industry which has a requirement for a flexible electronics circuit, and also biodegradable one. Okay, because this is sustainable because of the production technology and also the raw material what we use. Then the ink, we are making this functional ink with different kind of 2D materials, and this can be compatible with any kind of substrate. Even with PET, it's actually compatible. We can print it on such kind of PET substrate also on this. But the advantage of our ink is that our substrate is that when we print it on PET, it will peel off. Okay, you can, if you take a scotch tape, stick it over it and peel it off, it would come. But if you are doing it in our substrate, it won't come. See,
can you explain the end of life process for yours and for a conventional one?
Yeah, end of life process is like it's biodegradable. You can throw it in the environment. Okay.
और जो इसके ऊपर ये
yeah, major thing is, see here you can see lot of components are there. No,
right.
These components you have to pick it out, and then only you can decompose this. But on decomposition, this volume is huge compared to ours. Okay, and another thing is end of life, you have to use lot of chemicals or thermal energy to decompose this. Okay, but in our case you can throw it to the environment. It won't create any kind of hazard to the environment or human because of the biocompatibility. This is mere cellulose. And that too, European Union is entering into such domains and making clear policy decisions that should come to developing countries like us also. So in that level we have to push, like at least 25% of your components should be from sustainable source, green source, and then only this electronic industry, whoever want to enter into the system would think about it. If policy level regulation is not there in place, what people will do? They won't think about this, no. So in that way we want to price our components or service in par with whatever available in the market. Even though it's very difficult, we are looking into that.
So what are the applications, कहाँ कहाँ पर ये use हो सकता है?
Yeah. So first of all, this material I said, this is a biocompatible material, and it's flexible, and it's because of this flexibility, we can use in wearable applications, wearable sensors, wearable watches, or many kind of devices, gadgets are coming, and in that situation we can use this material. That is the first thing. And then we can use in different sensors, these kind of sensors we can use. For example, this is a sensor, self-powered sensor, and which can be used for sensing urea level, or from the sweat, or from any body fluids we can sense the electrolyte levels, and it can give data. Okay, so these, most of the case these kind of things are single use, or a short span of time, so that contribute normal traditional thing, traditional in the sense conventional products are mostly with many polymer based or synthetic materials, and that we can replace using this material. That is another advantage. And then mostly into the tags, these kind of tags. In many situations we use RFID tags in libraries, books, clothes, or in warehouses we use RFID tags, and most of the case they are single use. In some situation it will be long term use. In those situations we can replace the substrate for printing with this material. Okay, that is the another application. Yeah. So then again in the sensor we can use for strain gauges, and this material is just a strain gauge like a normal strain gauge, but this have a better sensitivity because of this particular ink, and the variation of resistance is much more than traditional materials, traditional sensors for a given extension. Okay, so this will give a better gauge factor. It's a technical term which we use to define the sensitivity of a strain gauge. Okay, so mainly sensors, we can say biosensors, other sensors, then these kind of tags, wearables. These are the major applications which we are looking into, because we can, in some situation we need a rigid PCB. Right. So in such situation this may not be immediately applicable, but we are trying to develop by making different layers, and using this material we are trying to make a rigid PCB as well. So that will be future that we are working on.
Do you think that green electronics is the future for India?
Yeah, so definitely a huge share will be there for this, because most of the single use or use and throw kind of electronics, many sensors are there. For example, even the sugar testing strips, these kind of strips we can make out of this, because the major contribution of the microplastic pollution is these kind of things. Right. Okay, so that can be replaced. That is going to bring a huge impact in terms of water pollution, soil degradation, all those things. Yeah, that is a major advantage.
Our journey started in 2019. From there onwards, when we started our journey, we found that there is no indigenously developed sensor available. Okay, for everything we have to rely on Taiwan or China, or we have to go to some European countries. Finally, what we did is we reverse engineered everything. We replaced this PET with this sheet. So this is how the past 5-year journey was for us. And even then, scaling is one problem we face because of the fund as well as the technology's own limitations. We are facing it, but we think with our 20 plus years of knowledge in R&D, materials, technology, we could able to overcome this. Yeah.
Follow Bharat Climate Startups for more such stories, and I am going into the rain. Bye bye.